I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this.
Color options. The highlight of this project is the automatic hitching system. It uses a servo-powered magnetic connector that not only physically latches the trailer but also transfers power and data, eliminating the need for trailer batteries or extra controllers. Through serial communication, the truck can send commands to the trailer, like raising landing legs or lowering a ramp, with a single button press. Use high-efficiency bearings to handle heavy loads while minimizing resistance. Front-wheel drive and U-joints add off-road capability and better control. The electronics are laid out on a custom PCB that keeps the wiring clean and allows full customization. Each motor or LED can be programmed to respond however you like. Number 10. If you always wanted one powerful, all-in-one controller that can wirelessly control almost anything, robots, vehicles, lights, or custom devices, and also be flexible enough for future upgrades, then this project is just for you. It includes 2 large joysticks for movement, 2 small joystick buttons that act like mini arrow keys, toggle switches and knob, 2 screens to show live information like sensor data, speakers and a microphone, a motion sensor, gyro, and a rechargeable battery. Number 9. Our next project is a smart wall switch with added features. It controls lights, works as a nightlight, simulates sunrise, detects presence, and connects with smart home systems like Home Assistant, all in one compact unit that fits into standard wall boxes. The switch can be controlled manually, through automation, or from a phone. It uses a microwave presence sensor for motion detection, which is more sensitive than traditional PIR sensors, even detecting subtle movements like breathing. The front panel of the switch is made from clear acrylic, engraved with custom designs like characters or icons. RGB LEDs light up the panel, working as a soft nightlight or gradually brightening in the morning to simulate sunrise. Number 8. This interesting project will guide you on making a DIY-free dark sky meter, an instrument to measure light pollution using simple and affordable components. At its core is an ESP32-C3 microcontroller, which handles data collection and wireless communication. The ESP32 reads inputs from a light sensor to measure sky brightness, along with a temperature and humidity sensor to log atmospheric conditions that can affect light pollution readings. The captured data is transmitted via MQTT to a remote server for storage and analysis. What's impressive is that this affordable setup, costing under $65, produced results that closely match those from ESA's Gaia satellite, proving that even hobby-level gear can yield scientifically reliable data. Everything from the firmware to the 3D printed case design is open source, allowing anyone to replicate or modify the system for their own location or research. And because of ESP32's low power consumption and Wi-Fi connectivity, this device is well suited for continuous outdoor operation. Before we move on to our next project, a word from our sponsor. Altium Designer lets you easily move from drawing your circuit to simulating its behavior, and then straight into PCB layout, all without needing multiple programs. On top of that, Altium 365 takes your work online. It allows you to view, edit, and share your designs from anywhere. You can even invite team members or manufacturers to review your projects directly through a web browser. They can leave comments, suggest changes, and double-check important details like component placement or spacing without needing the full software installed. This makes working with teams or preparing for production much easier and helps you catch mistakes before they become expensive problems. And the best part, you can get a 25% discount if you register using the special link we've added in the description. Give it a try. It might just be the upgrade your workflow needs. Number 7. This is SolarLink. The goal of this project is to increase solar energy output by keeping the panel pointed directly at the sun. Unlike fixed panels, this setup constantly adapts to the sun's position. The system uses two LDRs placed at different angles around a central divider. These sensors detect where the sunlight is strongest. Based on their readings, the ESP32 calculates whether the solar panel needs to tilt or rotate. The project is efficient and avoids unnecessary movements. Number 6. This project demonstrates how to build a compact, low-cost ECG monitor using an ESP32 microcontroller and an ECG sensor. The sensor captures the heart's electrical signals, while the ESP32 processes and streams this data wirelessly to a smartphone or computer for real-time monitoring. One best feature of this monitor is that the entire setup is simple and portable. Despite its minimal component count, it reliably records clean ECG waveforms and even flags irregularities like arrhythmias, all without the need for bulky medical equipment. You can find out more about this project in this research paper, which is linked in the description. Number 5. This project is an AI-powered diagnostic system for water-based HVAC cooling setups. It uses sound and heat data to detect fan failures and overheating problems before they get serious. To demonstrate it, Akhtar created a simplified setup using parts from PC water cooling systems, like a pump, radiator, aluminum blocks, and a custom 3D printed coolant tank. He also built a small CNC router to move a thermal camera around the system for scanning. Since there were no public datasets available, he created his own by simulating hardware failures. Using this data, he trained 2 machine learning models, one to catch unusual fan sounds, and another to detect heat issues from thermal images. He also made a custom web dashboard to manage data, control the system, and run the models. It even sends alerts with a message when something goes wrong. Number 4. This project is a DIY step counter designed using the Waveshare ESP32S3 board with a 1.8-inch touchscreen, speaker, battery, accelerometer, and power management system. Unlike a smartwatch that tracks steps passively throughout the day, this project takes things to the next level. It allows the user to set specific parameters such as step sensitivity, step length for accurate distance, and your weight for calorie estimates. All these settings are stored, so nothing is lost when the watch is turned off. It's power efficient, with a screen that turns off after 8 seconds and a low refresh rate to save battery. You get around 2.5 hours of active use per charge. All processing is handled locally, and while GPIOs are hidden for compactness, they can be accessed by modifying the enclosure if needed. Number 3. Imagine having a sleek modern fridge calendar that syncs directly with your Google Calendar. No pens, sticky notes, or clutter. That's exactly what Eric has built. This e-paper calendar fetches Google Calendar data, displaying up to 6 upcoming events neatly and intuitively. It's battery-powered and refreshes daily at midnight to keep everything up to date. All updates are handled seamlessly through the Google Calendar app. The e-paper screen draws events one by one, which may take longer, but it creates a mesmerizing effect during updates. Instead of using a 3D printer, Eric repurposed an old picture frame for the housing. While it might not be a commercial-grade product, it's incredibly practical for family use, letting everyone stay on the same page effortlessly. Number 2. Our next project is a simple fluid motion simulator that visually demonstrates how liquids, gases, or particles move under different conditions. Here, Mirko used a 16x16 WS2812B LED matrix controlled by an ESP32 microcontroller. He paired it with an MPU 6050 accelerometer and a single button that simulates basic fluid dynamics in real time, responding to device orientation and motion. The project is housed in a recycled enclosure with an optional 3D printed grille to enhance visibility. The simulator supports customizable parameters, like the number of particles, LED brightness, and color modes. You can cycle through predefined colors or use a version of the code that changes particle color dynamically based on position for added visual depth. Though the resolution might seem low as it has only 256 LEDs total, the visual output is compelling and helps convey core principles of fluid movement. Number 1. This project is a smart water quality monitoring system designed to catch early signs of underwater pollution by spotting air bubbles and analyzing chemical test results. To simulate polluted water conditions, Akhtar set up a planted freshwater aquarium and connected the system to it. The air bubble detection unit uses a nano ESP32 with an ultrasonic sensor, an accelerometer, and a small display. It collects scanned data, runs a trained model to detect harmful air bubbles in real time, and sends the results to a web server. For chemical testing, he used a single board computer with a webcam and touchscreen that checks water test strips and sorts them into pollution levels. Both boards are linked to a custom web app and send updates through a Telegram bot. To bring everything together, a custom squid-themed PCB and a 3D printed mount were added to the aquarium. If you've made it till here, then drop a like and subscribe to our channel to keep supporting us. Comment the project that you loved the most. We will be back with some great ideas soon. Till then, goodbye.